Hello, we're going through some pretty complicated math here today. This is where we get our size estimates, population estimates, density estimates, things like this. So these are just measured from the Blender file. This is our top trapezoid from the diamond and the bottom trapezoid from the version 7. This is not including version 9. So you'd have to add to the cost, add to the population. You have your average height, 15 stories, that's 5 hexagons. This is how packed the hexagons are. So how packed the space is. This might actually be maybe 0.8. Because you have to figure the roads are in here too. So maybe we'll do, including roads, maybe we're going to do 65% residential. So this is our total square feet. We just multiply out this. We get our square feet, 761% larger than the world's largest building. This is counted out manually for the stadium in the center as well as the amusement park hexagons. This is for the XY plane, and then you have to multiply it by the height. So this is only XY. So anyway, you add all this together, do all this math using the square feet, you get about 6,000 hexagons to construct version 7. Cost per hexagon, this is a rough estimate, 600,000. Do the math, 3.6 billion for total cost. So I usually tell people like 3 to 5 billion is the estimate, because this is in the mid-range. It might get a little lower than this when we start mass production. So this is one of the issues. I say 144,000 residents. This is significantly off 144,000, but if you include version 9, you might bump up to like 100,000 here with version 9. And this is your average population per cell. If this is like, let's say 18 bedrooms per hexagon, that would be 25 people. You're at about 100,000 roughly. So all these numbers are kind of they ebb and flow. Total acres, this is just a measurement. This one's pretty accurate. Residents per square mile, you just do the math here, you divide, you get 200,000. This is square feet per person. You take your total square feet, divide by 100,000, you get 1,600 square feet per person. That's not too bad. Not too bad at all. And then this is your cost per resident for construction. In a lot of videos I say like 25,000. That might be on the low end, obviously. 36 I think might be a little bit more reasonable. In a lot of my videos I say it's 4 times denser than Manhattan. Actually, more accurate, 2.6 times denser than Manhattan. So I say 75 times denser than suburbia often. I actually looked up my suburbia. Here I'm going to dox myself. I looked it up. It's actually 2,400 people per square mile instead of the original 4,000 I thought it was. So that brings it up to 83. We have a 9.1 commute reduction multiplier at 15 times, or 15 miles an hour times by 9. You get 137 miles an hour is your relative travel speed. This is man hours of construction per hexagon. This is a wild estimate. We'll have a much better number for this once we start construction. But so it takes 2,000 hours to build a hexagon, which I think might be a little bit on the low end. So this is man years for the whole city. You just multiply it by the number of hexagons. And yeah, so that means 6,000 people could build the city in a year, which I think might be a little bit on the low end. We might have to bump this one up. This one is not necessarily accurate. We have our average car ownership rate. This is a space for a parking lot. Just your parking space. Then you do the math. Parking area required. You need a 400-acre parking lot for the whole city. But assuming a car share, you only need 5% vehicles. You multiply 5% by 395 and you get your new parking lot area of 20 acres. And with this population of 97,000, this means you can calculate with this 0.82, you take 75,000 cars off the road, which is the equivalent of 144 linear miles of street parking. That's both sides of the road. So 144 miles of street parking. Incredible. So nuts. So I also have the interior parking lot math done in a different video, and I think we needed only like 100 like small parking lots for the whole city, something like that, maybe 200. But like this percent residential will have better numbers once we start building out the city. Average population per cell will have better numbers when we build out the city. But these are all decent. These are decent estimates. You can see that they're really probably within plus or minus 20%. Maybe not that much. Maybe like plus or minus 15%. I think is a reasonable estimate. So they're not precise, they're not exact, but they're within the realm of reason. So yeah, that's how a lot of the stuff is derived. People have questioned the numbers, they've questioned the logic, they've questioned the reason behind the numbers and behind the arithmetic and algebra, and I just walked you through it to give you a better idea on just where a lot of these numbers come from. And this is really like the core mathematics of the city. This is really like the foundation of the mathematics, and a lot gets built off of this. Anyway, I'm gonna wrap it up there, and remember, a single dream is more powerful than 1,000 realities.